Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Food preservation and additives. Effective techniques for home and industry use. Table of contents. Introduction to food additives and preservatives. Sources of additives. Functions of food additives. Classification of food additives. Regulation of food additives. Introduction of food preservatives. Types of food preservatives. Common food preservation techniques. Introduction to food additives and preservatives. A food additive is any substance intentionally incorporated into foods to modify their appearance, taste, texture, or aroma. The primary purpose of food additives is to extend the shelf life of foods, inhibit the growth of pathogens, and adjust other properties of the product. While food additives are not considered regular ingredients or consumed as standalone foods, they are rigorously evaluated for potential health risks before their use is approved. According to the Codex Alimentarius Commission, a joint organization by FAO and WHO for establishing food standards, and the EEC Commission, a food additive is defined as any substance that is not typically consumed as food on its own and is not commonly used as a food ingredient, regardless of its nutritional value. Food additives are essential throughout the stages of food production, including manufacturing, processing, preparation, treatment, packing, packaging, and transport. Within the European Union and EFTA, these substances are assigned E numbers on food labels to indicate that they are permitted for use. Some of the most common food additives include monosodium glutamate, MSG, often found in packaged Asian foods, artificial sweeteners, such as aspartame, saccharin, and sodium cyclamate, antioxidants, used in foods containing fats or oils, benzoic acid, commonly added to fruit juices, sulfites, found in packaged vegetables, nitrates and nitrites, added to hot dogs and other meat products, antibiotics, administered to food-producing animals, lecithin, gelatin, cornstarch, waxes, gums, and propylene glycol, used as stabilizers and emulsifiers in various foods. The FDA regulates and ensures that food additives used by manufacturers are safe and approved for specific applications. Food additives are crucial in food processing. They are added in controlled amounts to enhance appearance, flavor, and nutritional value. They help maintain the nutritional quality, improve food stability and quality, and reduce food waste, making food more appealing to consumers. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Sources of additives. Additives can be categorized into three main types: natural additives, man-made additives, artificial additives, natural additives. These additives are derived directly from natural sources like plants and animals. For example, beetroot juice extract is commonly used as a natural coloring agent. Man-made additives. These are synthetically produced replicas of natural substances. An example is benzoic acid, a synthetic version of a natural compound used as a preservative. Artificial additives. Artificial additives are entirely synthetic and do not exist in nature. Examples include sulfur dioxide and sorbic acid, which are often used in specific dairy products, as well as in semolina and tapioca puddings. Functions of food additives. Maintaining product consistency. Additives help ensure consistent quality across products. Emulsifiers. Prevent the separation of ingredients, maintaining a uniform mixture. Stabilizers and thickeners. Provide smooth, even textures in foods. Anti-caking agents. Keep ingredients free-flowing, preventing clumping. Nutritional preservation. Additives can enhance or preserve the nutritional content of foods. Wholesomeness. They help maintain the overall safety and quality of food. Preservatives. Reduce spoilage and prevent rancidity. Acidity and alkalinity control. Aid in balancing acidity levels and support leavening processes. Flavor and color adjustments. Adjust acid-base levels to achieve desired taste, color, and flavor. Color and flavor enhancement. Provide appealing color and boost flavors in foods. Preventing clumping. Anti-caking agents help avoid lumping in fine or powdery substances. Classification of food additives. Food additives can be classified into two categories. 1. Intentional food additives. Second, unintentional food additives. First, intentional food additives. These are substances deliberately added to foods to assist in processing, improve quality, and preserve the product. They help prevent spoilage and enhance various aspects of food. Examples include anti-caking agents, antimicrobial agents, antioxidants, colors, curing and pickling agents, emulsifiers, enzymes, firming agents, flavor enhancers, flavoring agents, humectants, leavening agents, release agents, non-nutritive sweeteners, nutrient supplements, nutritive sweeteners, oxidizing and reducing agents, pH control agents, propellants and gases, sequestrants, solvents and vehicles, stabilizers and thickeners, surface active agents, texturizers, second unintentional food additives. These additives are not purposefully added to food, but may enter inadvertently during various stages of food production, including agriculture, animal raising, food processing, packaging, and storage. They are considered food contaminants. Examples include insects or herbicides from the field when processing grains, pesticides to prevent infestations, hair from unsanitary processing conditions, wax from products stored in wax-coated packaging. Additional examples include processing aids, food contact materials, packaging materials, cleaning agents, ion exchange resins, filter aids, enzyme preparations, microorganisms, solvents, lubricants, release agents, specific function additives, utensils, working surfaces and equipment, metal, plastic, paper, wood, etc. Detergents, sanitizers. The different types of food additives include preservatives, antioxidants, sequestrants, humectants, bleaching and maturing agents, starch modifiers, emulsifiers, stabilizers, gelling agents, and thickeners, surface active agents, anti-caking agents and anti-foaming agents, colors, flavor enhancers, acids, bases, and buffers, glazing agents, nutrient supplements, enzyme preparations, preservatives. Prevent or slow the growth of microorganisms that cause food spoilage and food poisoning. Extend the shelf life of products. Examples: bacon, ham, corned beef, and other cured meats, treated with nitrite and nitrate, E249 to E252, during the curing process. Antioxidants. Prevent oxidation of foods containing fat or oil. Stop rancidity, which involves the development of unpleasant odors or flavors. Prevent spoilage of animal fat caused by oxidation. Prevent browning of cut fruit, vegetables, and fruit juices, helping to prolong shelf life and maintain appearance. Example: vitamin C, ascorbic acid, E300, one of the most commonly used antioxidants. Sequestrants. A sequestrant is a chemical that binds with a substance and isolates it, allowing it to be removed from the food. These additives prevent metal ions from oxidizing fats in foods. Examples include sorbitol and phosphoric acid. Humectants. Humectants are substances that bind moisture and reduce water activity, acting as moisture retention agents. They help control viscosity, texture, crystallization, and bulkiness in foods. Traditional humectants include honey, salt, and sugar. 4 polyols: sorbitol, E420, mannitol, E421, glycerol, 422, also known as glycerine, and propylene glycol, E1520, are commonly used to improve texture and retain moisture in food products like coconut and other food items. Bleaching and maturing agents. Starch modifier. Bleaching and maturing agents such as chlorine dioxide, bromate, iodate, and chlorine are used in flour. These chemicals help speed up the natural aging process of flour. In cheese, bleaching agents are used to give a white color. Benzoyl peroxide and hydrogen peroxide are used to bleach tripe, meat. Emulsifiers, stabilizers, gelling agents, and thickeners. Emulsifiers, e.g., lecithins, E322, help combine ingredients that would otherwise not mix. Stabilizers, e.g., locust bean gum, E410, prevent ingredients from separating. Emulsifiers and stabilizers help maintain a consistent texture in foods, often found in low-fat spreads. They also inhibit crystallization, stabilize emulsions and foams, reduce the stickiness of icings on baked products, and help encapsulate flavors. Gelling agents, e.g., pectin, E440, improve food consistency and are commonly used to make jam. Thickeners help provide structure to foods and are commonly found in sauces. Surface active agents. Lecithin, an emulsifier, is an example of a surface active agent. It is added to baked goods to make the dough easier to work with and to improve the appearance of bread. Anti-caking agents, anti-foaming agents. Anti-caking agents prevent particles from clumping together, allowing for better flow. They are commonly used in products like dried milk or table salt. Anti-foaming agents prevent or reduce frothing, bubbles, in liquids, such as during the production of fruit juices. Silicon dioxide, E551, is a key anti-caking agent, while other examples include calcium silicate, E552, sodium aluminosilicate, E554, and dicalcium phosphate, E341. Natural anti-caking agents include talc, kaolin, potato starch, and microcrystalline cellulose, E460. A comprehensive list of anti-caking agents with their E numbers includes E341, tricalcium phosphate, E460, RT, powdered cellulose, E470, B magnesium stearate, E500, sodium bicarbonate, E535, sodium ferrocyanide, E536, potassium ferrocyanide, E538, calcium ferrocyanide, E542, bone phosphate, E550, sodium silicate, E551, silicon dioxide, E552, calcium silicate, E553, A magnesium trisilicate, E553B, talcum powder, E554, sodium aluminosilicate, E555, potassium aluminum silicate, E556, calcium aluminosilicate, E558, bentonite, E559, aluminum silicate, E570, stearic acid, E900, polydimethyl siloxane. Permitted anti-caking agents include calcium aluminum silicate, calcium phosphate tribasic, calcium silicate, calcium stearate, cellulose, magnesium carbonate, magnesium oxide, magnesium silicate, magnesium stearate, microcrystalline cellulose, propylene glycol, potassium ferrocyanide trihydrate, silicon dioxide, sodium aluminum silicate, sodium ferrocyanide decahydrate. Colors. Food colors help restore the color lost during processing or storage, such as with marrow-fat peas. They ensure that each batch of food looks consistent and does not appear off or unappealing. Colors enhance the visual appeal of foods, such as giving custard a rich yellow hue. They are used to provide color to otherwise colorless foods, like soft drinks, making them more attractive. Some artificial colors, including sunset yellow E110, quinoline yellow E104, carmazine E12, 2, allura, red E12, 9, tartrazine E102, and Ponceau 4 RE124, have been linked to negative effects on children's behavior. These colors are often found in soft drinks, sweets, and ice cream. The Food Standards Agency recommends avoiding these additives if a child shows signs of hyperactivity or attention deficit hyperactivity disorder, ADHD. Flavor enhancers. Flavor enhancers are used to intensify the flavor of foods without adding their own distinct taste. Monosodium glutamate, E612, is commonly added to processed foods such as soups, sauces, and sausages to enhance flavor. Flavorings, which are typically added in small quantities, impart specific taste to food. Synthetic flavor enhancers include amyl acetate, for a banana flavor, and methyl anthranilate, for a grape flavor. Acids, bases, and buffers. These additives regulate the acidity or alkalinity of food, ensuring the safety, stability, and proper flavor profile of the product. Glazing agents. Glazing agents are used to create a shiny, protective layer on the surface of foods, such as in confectionery, to improve appearance and extend shelf life. Sweeteners. Sweeteners are classified into two types: intense sweeteners and bulk sweeteners. Non-nutritive sweeteners, such as saccharin and aspartame, provide sweetness without adding significant calories. Nutrient supplements. Nutrient supplements, including vitamins, minerals, and amino acids, enhance the nutritional content of foods. They help replace nutrients lost during processing and storage, contributing to a higher nutritional value. Examples include the addition of vitamin C to canned fruits and the use of thiamine, niacin, and iron in cereal products. Enzyme preparations. Enzyme preparations are additives that may or may not remain in the final food product. These enzymes, which are naturally occurring proteins sourced from plants, animals, or microorganisms, such as bacteria, serve as alternatives to chemical technologies. Enzymes break down large molecules into smaller components and stimulate biochemical reactions. They are primarily used in baking, to enhance dough, fruit juice production, to increase yields, winemaking, brewing, to improve fermentation, and cheese production, to facilitate curd formation. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Regulation of food additives. The Food and Drug Administration, FDA, monitors all foods, except meat, poultry, and eggs to ensure safety for consumer consumption. It regulates and permits the use of food additives. The United States Department of Agriculture, USDA, through the Food Safety and Inspection Service, FSIS, monitors added growth hormone levels in animals. The Food, Drug, and Cosmetic Act, 1938, grants the FDA authority to regulate food and its ingredients, including ensuring proper labeling. The Food Additives Amendment, 1958, requires manufacturers to provide evidence of the safety of additives and obtain FDA approval before they can be used in food or food processing. The GRAS list includes approximately 300 additives deemed safe for consumption based on scientific evidence. The Color Additives Amendment mandates that color additives must be certified as safe, with only 30 color additives approved for use in food products. The Delaney Clause states that any additive found to cause cancer in humans or animals is considered unsafe. Advances in technology now allow the FDA to approve additives with a cancer risk of 1 in a million or less as safe. Food manufacturers must list all ingredients, including additives, on the label in order of weight. Labels containing artificial colors or artificial flavors indicate the use of synthetic colors or flavors, allowing consumers to make informed decisions. The Food and Agriculture Organization, FAO, ensures food security and safe food access for all people. The World Health Organization, WHO, provides international leadership on critical health issues and trends. Introduction of food preservatives. Food preservation involves the use of chemicals or substances added to food to prevent deterioration. Food can spoil due to enzymatic, physical, chemical, or microbiological processes, which can reduce its quality, safety, and nutritional value, and result in undesirable changes in its physical and sensory properties. Various preservation techniques are used to address this issue, and preservatives are a key method in food processing to maintain quality and prevent contamination. Preservatives help inhibit or slow down the growth of microorganisms that cause food spoilage and foodborne illnesses. They also extend the shelf life of products, keeping food safe and suitable for consumption for longer periods. Examples of commonly used preservatives include salt, sugar, vinegar, and pepper. Saltpeter or sodium nitrate, used in meat curing. Sulfur dioxide, sulfurous acid, and sulfides, used to prevent discoloration of cut fruits and act as anti-browning agents. Benzoic acid or sodium benzoate, used in fruit juices, jellies, margarine, and ketchup. Citric acid and tartaric acid, used in syrups, drinks, and jellies to enhance flavor. Alum and soaked lime, also known as APOG, used as firming agents for pickles and fruit preserves. Types of food preservatives. Food preservatives can be classified into two categories. 1. Natural preservatives. 2. Artificial preservatives. 1. Natural preservatives. These are derived from natural sources such as plants. Examples include sugar, salt, and citric acid, obtained from citrus fruits. 2. Artificial preservatives. These are synthetic preservatives created in laboratories. Examples of artificial preservatives include sodium benzoate, used in soft drinks, salad dressings, and canned tuna. Calcium propionate, found in baked goods, processed meats, and dairy products. Potassium sorbate, used in cheese, wine, and dried meats. BHA and BHT, commonly found in margarine and potato chips. TBHQ, used in pasta, cereals, and nuts. Artificial preservatives are further categorized into subgroups: antimicrobials, antioxidants, and anti-browning agents. A. Antimicrobials. Antimicrobial compounds, natural or synthetic, are used to inhibit the growth of microorganisms, bacteria, yeasts, molds, and control contamination by pathogenic organisms, ensuring food safety and quality. Antimicrobials are identified by E and INS numbers ranging from 200 to 290, and they help extend the shelf life of food. Excessive use of antimicrobials can cause unpleasant tastes, strong odors, changes in viscosity, and affect color retention. Synthetic preservatives are chemical substances that prevent the growth of bacteria, yeasts, and molds. They are officially recognized by regulatory bodies for use in food. Approved synthetic preservatives include inorganic acids and their sodium salts, e.g., nitrite and sulfate, and weak organic acids such as benzoic acid, sodium benzoate, and sodium propionate. Benzoic acid disrupts cell membrane function and inhibits enzymes in molds, yeasts, and some bacteria. Propionic acid interferes with cell membrane function in molds and some bacteria. Despite their benefits, the use of chemical antimicrobials is controversial due to potential health concerns. Common examples include acetic acid, benzoic acid, lactic acid, malic acid, E296, fumaric acid, E297, citric acid, E330, and other organic acids. Sodium sorbate and parabens can be harmful to human health. There is growing demand for natural preservatives, which are considered safer for both human health and the environment. Natural preservatives are derived from plants, bacteria, fungi, and animals. Natural antimicrobials can be classified as 1. Plant-based antimicrobials. 2. Animal and microbial-based antimicrobials. First, plant-based antimicrobials. Many plant extracts, such as herbs and spices, have preservative properties with antimicrobial activity against various microorganisms. The effectiveness of plant-based antimicrobials depends on the type, nature, and concentration of the extract, which can extend the shelf life of food. Types of plant-based antimicrobials include essential oils, phenolic compounds, polypeptides, lectins, alkaloids, polyamines, organic acids, glycosides, glucosinolates. Essential oils, EO, are bioactive, complex volatile compounds produced by aromatic plants. EO are used as flavoring agents in the food industry and also act as natural antioxidants and antimicrobial agents for food preservation. Second, animal and microbial-based antimicrobials. Animal and microbial-based antimicrobials are derived from natural sources, including plants, insects, amphibians, crustaceans, and marine organisms. Examples of animal-based antimicrobials include lysozyme, an enzyme used as a preservative in meat, fish, milk, dairy products, fruits, and vegetables. Lactoferrin, found in milk and other secretions, it has iron-binding properties. Catheliticin, found in mammals, it exhibits activity against bacteria, fungi, and viruses. Lactic acid bacteria, LAB. Lab produces antibacterial compounds such as bacteriocins, organic acids, ruterin, diacetyl, ethanol, CO2, H2O2, and lactic acid derivatives. Lab is used in the production of fermented products like sausages, cheeses, and yogurt. Bacteriocins. These are ribosomally synthesized antimicrobial peptides that have bactericidal or bacteriostatic effects. They are used in food preservation, especially for meat and vegetable products. Some bacteriocin-producing strains include Carnobacterium, Lactococcus, Lactobacillus, Pediococcus, Leuconostoc, and Propionibacterium. Nisin, a bacteriocin synthesized by Lactococcus lactis. Nisin disrupts cell membrane function in gram-positive bacteria and lactic acid-producing bacteria. It is the only bacteriocin with GRAS status for global food industry use, known for its excellent antibacterial properties. B. Antioxidants. Antioxidants, INS 300-326 and E300-E326, prevent autoxidation and help preserve dry and frozen foods. Two types of oxidation occur during food storage. 1. Lipid peroxidation. 2. Rancidification. First, lipid peroxidation. This process occurs when oxidants, such as free radicals or non-radical species, attack lipids with carbon-carbon double bonds, polyunsaturated fatty acids, PUFAS. It involves the abstraction of hydrogen from carbon, followed by the insertion of oxygen, resulting in lipid peroxyl radicals and hydroperoxides. Lipid peroxidation proceeds through 3 stages: initiation, propagation, termination. Second, rancidification. Rancidity refers to unpleasant odors and flavors caused by lipid oxidation or lipolysis, the breakdown of oils into fatty acids either chemically or by lipase. This occurs during food storage when fats and oils are exposed to air, light, moisture, and bacteria, leading to hydrolysis or oxidation that makes the food unfit for consumption. Rancidity develops in 3 stages: initiation, propagation, and termination. There are 2 types of rancidity: oxidative rancidity, caused by the oxidation of fats, often catalyzed by heat, ultraviolet light, heavy metals, and oxygen. Forms toxic compounds like peroxides that can damage vitamins A and E in foods, leads to undesirable odors and flavors in oils and fats, e.g., lard, shortening, cooking oils, over time when exposed to air. Hydrolytic rancidity results in unpleasant odors due to the release of free fatty acids from triglycerides, caused by fat hydrolysis, where triglycerides, composed of 3 fatty acids, break down, makes foods unsuitable for consumption due to the release of free fatty acids. Antioxidants play a key role in scavenging free radicals and oxygen, preventing peroxidation during the initiation or propagation stages, which helps extend the shelf life of food. They inhibit the oxidation of fatty acids, including BHA, E320, and BHT, E221. BHA is more commonly used in animal fats than in vegetable fats for food preservation and coatings, while BHT is used in animal fats and dry breakfast cereals. However, both are harmful to human health. Gallate compounds, E310 to E312, are often used alone or in combination with BHT and BHA. These compounds are found in dried milk, fats, oils, nut butters, potato products, chewing gums, cereals, meats, nuts, and food supplements. EFSA-approved chemical antioxidants include ascorbic acid and its derivatives, E300 to E304, used in dairy products, chewing gums, cereals, meats, desserts, salads, sauces, and other foods. Other approved antioxidants include EDTA, E385, erythorbic acid, E315, sodium erythorbate, E316, citrates, E330 to E380, lactates, E325 to E327, tartrates, E334 to E354. Functions of antioxidants: ascorbic acid, oxygen scavenger; BHA, butylated hydroxyanisole; free radical scavenger; BHT, butylated hydroxytoluene; free radical scavenger; citric acid, enzyme inhibitor; metal chelator; sulfites, enzyme inhibitor, oxygen scavenger; tertiary butyl hydroquinone, TBHQ, free radical scavenger; tocopherols, free radical scavenger. Applications of antioxidants: calcium ascorbate, E302, prevents browning in freshly cut fruit, commonly used in dairy and cured or cooked meat products; potassium citrate, E332, and calcium citrate, E333, used to modify intense flavors and found in jellies, marmalades, pH buffers, sequestrants, antioxidants, and cheese; tartaric acid, E334, and its derivatives, sodium E335, potassium E336, calcium E336, applied in chocolates, marmalades, gelatins, canned food, fresh pasta, cheeses, fats, oils, meats, and sausages; phosphoric acid, E338, and its salts, work synergistically with citric acid to prevent fat oxidation in soft drinks, fruit jellies, cheese, and yeast powders; sodium phosphate, E339, used in pasta, meat, powdered milk, fruit, cheese, snacks, and ready-made desserts. It has chelating and antimicrobial properties, enhanced by its synergy with lysine; potassium phosphate, E340, found in meats, bread, pasta, powdered juices, eggs, and sausages; calcium phosphate, E341, applied in the baking industry, fruit preserves, powdered juice flour, cheese, and porridge; ammonium phosphate, E342, and magnesium phosphate, E343, used in bread, pasta, cookies, and pancakes. Adipic acid and its salts, used in cheeses, jellies, and canned fruit. Succinic acid, found in chicken meat, dairy products, and cooked foods. Calcium disodium, EDTA, 385, used in poultry, processed meats, vegetables, fruits, juices, and beer. Rosemary extract, a natural antioxidant. C. Anti-browning agents. Anti-browning agents are used to prevent both enzymatic and non-enzymatic browning in food products such as dried fruits and vegetables. Enzymatic browning. Enzymatic browning occurs when polyphenols oxidize to form quinones, a reaction catalyzed by the enzyme polyphenol oxidase, PPO, also known as tyrosinase, O-diphenol oxidase, or catechol oxidase. The quinones then polymerize, causing the browning effect. This process primarily occurs in raw fruits and vegetables rather than those that have been blanched or thermally processed. It occurs naturally in various organisms, including fungi, bacteria, and higher plants such as mushrooms, apples, potatoes, pears, bananas, peaches, and avocados. Enzymatic browning is triggered by factors such as physiological injury, senescence, bruising, both pre- and post-harvest, and disruption of fruit or vegetable tissues through peeling, coring, slicing, or juicing. Additionally, freeze-thaw cycling and bacterial growth can cause tissue disruption, enhancing the browning reaction. The reaction occurs when phenolic compounds in plant tissues come into contact with oxygen. Mechanical injury and tissue damage reduce the integrity of the plant cell membrane, leading to the development of a brown color. Enzymatic browning in fruits and vegetables can also result from the loss of ascorbic acid, vitamin C, through its reaction with quinones. Blanching is commonly used to control enzymatic browning. Non-enzymatic browning. Non-enzymatic browning results from the Maillard reaction, which involves the interaction of carbonyl groups and free amino groups, such as reducing sugars and amino acids. This reaction produces melanoidin pigments, which contribute to the brown color in foods such as dairy, cereals, fruits, and vegetables. Non-enzymatic browning typically occurs due to heat and prolonged storage, causing discoloration in food products. To control this type of browning, excessive heat exposure should be avoided. Moisture content in dehydrated products should be regulated, and sulfites can be used. In food production, browning is a concern at various stages. When cut fruits and vegetables are exposed to oxygen, enzymatic browning occurs. Common additives used to control browning include vitamin C, E300, citric acid, E330, and sodium sulfite, E221. Sulfites help control both enzymatic and non-enzymatic browning, suppress microbial growth, and act as bleaching agents. However, sulfites are considered harmful to human health. As an alternative to sulfiting agents, ascorbic acid, vitamin C, is used as an anti-browning agent. Another alternative is koic acid, 5-hydroxy-2-hydroxymethyl gamma-pyrrone. The U.S. Food and Drug Administration has banned the use of sulfites in certain raw fruit and vegetable products. Examples of anti-browning agents: erythorbic acid, E315, used in beverages to preserve flavor. 4-hexylresorcinol, E586, an organic compound permitted only in shrimp. Calcium lactate helps inhibit browning in fruits by maintaining their structure. Ascorbic acid, vitamin C, E300, an antioxidant that prevents fruit from darkening. Common food preservation techniques. The common food preservation techniques are refrigeration, freezing, drying, and curing. Vacuum and modified atmosphere packaging, oxygen-free. Lactic fermentation. Sugar preservation. Ethanol preservation. Addition of weak acids, e.g., sodium lactate, carbon dioxide enriched atmosphere packaging, emulsification, pasteurization, food irradiation, use of preservatives, e.g., nitrite or sulfite ions, application of high hydrostatic pressure, pulse electric field processing. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!